Hi, in this video I'm going to demonstrate how to define self-centering fixture or Vise inside SolidCAM 2023 SP2. And there are a couple of things that you need to do before you really import those files inside SolidCAM, and that's are to decide which geometry will be splitted in this assembly and also to define relevant coordinate systems. So over here I have a Dressel C2 self-centering vise. It consists of these two jaws that are moving symmetrically outside and inside here. And as you can see, besides of this, what is pretty nice with this fixture, in order to expand the stroke and clamping capabilities, this fixture offers two positions where this can be mounted, and that can be actually very nicely visible in this position. What is also very nice to see, it will be very important to decide where my joint will be located. And you can see that the distance between this surface over here, the one that is selected, and one on the top, is exactly 0.3. I will need that later. Okay, my first geometry will definitely be this, that I'm going to call it a main body. It will consist of one coordinate system. On top of it, it will be one linear guider that will be on my linear axis. This linear axis will be also patterned, which means I'm going to create exactly the one and mirror it. So this one moves together with this one. And on this, it will be a jaw itself. So these are the three components that I needed for this Vise. So let's get started. So first, let's create a coordinate system here at the bottom that I like to call it main coordinate system for this body. I'm going to create a coordinate system. Now this coordinate system one is the reference based on the table. So if you have your table and your coordinate system, it's like this y-axis and here's the x-axis, this coordinate system is going to match this orientation. Of course, later inside the setup you can rotate the setup, but this is going to be a default orientation. I like to point that in this example, I'm going to use this as to my y-axis and this to be my x-axis. So let's take my x-axis over here. My y-axis will be this, and the z-axis will be this one here. That's perfect. I'm going to rename this coordinate system to main coordinate system. Right. The next one, I'm going to unhide it. It will be this linear join. I can place this coordinate system anywhere, or I can use this one for the reference. But in the cases when you want to use the AutoClose function inside SolidCAM, I'm going to show you later once we are going to test this fixture. AutoClose allows you to automatically close on the target. And this function works only if you are considering and looking at your Vise or fixture like in the chuck jaw system. So basically, you can imagine this as a chuck, and then you have your jaw. I'm not very creative here, but you are understanding what I want. And what we have here is we have the z-axis and we have also the x-axis. These jaws are moving in this direction. So this is the coordinate system that we are looking for. So because of that, and the rule that everything for the jaw system must be in x-plane, I'm going to create additional coordinate system that will be rotated according to this one. Let me just refresh this one so we can see the main coordinate system. Okay, so it will be placed over here in this edge, in the middle one. So I'm going to pick a middle point. I'm going to create a coordinate system here. My x-axis will be along this line. My z, or let's say my y-axis can be in this line, and the z-axis can be top of this. I will just flip my y so I get the x in this direction, and that will be it. I'm going to call this like a linear coordinate system. Okay, the next two things, what I need is the joints for these two jaws, and you can place it basically also on this surface. It can be also shifted for 0.3 along the z direction. It can be also mounted on this surface that I just selected. There are no rules. Depends on what is easier for you. I'm going to define a simple point here. Let me just do it actually differently. I can unhide this, and I can unhide Joe, and I can place it right in this face here. I think this will be the easiest way to do it. I'll just create a point in the middle of this and create a coordinate system. The coordinate system will be exactly the same where is this one over here. So the same orientation pattern. So X will be along here, this edge, Y will be this edge, Z-axis will be this edge, and yeah, I'm going to flip Y-axis. Perfect. So this will be my jaw position 1. Indeed, I'll have jaw position 2, but in this example, I don't want to show you. I want to show a couple of features that we have inside our toolkit. These 3 coordinate systems, they are enough for us to generate everything what we need for this particular self-centering Vise. So let's start with exporting. So I'm going to hide everything that is not in the main body, and I'm going to export it. I'll click Save, Save As, and I'm going to place it in this folder, just STL. Going to remove these, or let me just create a new folder. Just like that. And maybe I can also create additional folder for a particular model. This is the one. I'm going to copy this link. I will need it later. I'll click on the options. And for main body, I like to use a resolution as coarse. It's not necessary to go with a fine, as this is still a fixture. Optimization over your data, it's quite important. And of course, for the simulation performance later, try to minimize the data that you need. Do not translate STL output. This is a must. So don't forget to click on this one, always. Save all components of an assembly in a single file. This relates to all components that are visible. So that's a pretty nice option. And I'll select my main coordinate system. I'll click OK. I'm going to call this main and click Save. I'm going to repeat the same for the rest of the geometries. Hide this one. So Save As. I'm going to call this linear. Options. Click on the linear coordinate system. Coarse also. And click OK. Perfect. And the last is the job itself, but I want to emphasize on something. If you are exporting the STL, which has broken edges, or this is surface body, your STL is not going to be correct. And therefore, the auto-close, auto-clamping option will not work. Even though that you're looking at the 3D model, you think everything is okay, but at the end, it turns out that something is not working well. And in this particular job, I created this example where this body was actually not correct one. It was a surface. So if you go over here, you can see that this model, when it was imported, it was actually a surface. And you can see it has broken edges. This is a common feature that we have. And basically, with a couple of features, I was able to make a solid, and that's it. So I'm going to save it. And I'm going to export this according to my geo position 1. I'm going to click on STL. It will be my geo position 1. And this time, instead of coarse, because it's geo about, I like to use fine. fine resolution for this particular geometry. I'm going to click OK. And everything is okay. So I'm save, click OK, and we can continue. Now, this data, if I go to my folder where we export all of these, are located over here. These data here cannot be really used by our SolidCAM system and our toolkit. So I need to store this data into a default folder of SolidCAM where the toolkit can read this data. How you can know where this folder is? There are two ways how you can find it. You can go to the SolidCAM here on the right, and you can find the tool library manager, and you have the settings over here. Or you can also go to the tools, SolidCAM toolkit, and you have the settings also over here. So when the toolkit settings pops up, you are going to have here general, and you have a default folder. Default folder actually shows where this is actually stored. So I can now copy this, open Explorer, paste, and this is the place where I need to store all of my STLs of my fixtures or toolkit components. So let me just Alt-Tab it. I'm just going to copy this and just paste it here. So I have it also here and also my locally. From now on, I'm going to use it only this one here. So let's build a structure inside the toolkit. So again, you can do it from this menu. I'm going to click on New, and I'm going to first build it as a component, then as an assembly, and also later I'm going to use it in my part, just to show you to test it. Of course, definitely you can go directly to a part, but I want to show the whole process. I'll go to the tool components. And over here, I have the fixture menu. And over here, you have the fixture icon. There are only two components available, the main fixture body and the jaw. So you can easily just create a new folder and just drag and drop all the components inside. But I'm not going to do it like so. Instead, I will do it by using an option import structure. When you're doing this, it will pop up default folder. And you can select the folder that you have and just pick it up. It will automatically create all the subfolders that this folder contains, and also all parts that you have inside. It will be there, named correctly. As you can see, I will just open this and quickly check it up. And I will just use the stay in the last view. This coordinate system looks okay. A linear looks also fine. And also Joe's looks beautiful. Perfectly. What is the next? The job itself is a jaw. So therefore, it's not a fixture body. I'm going to convert it to a jaw. There you go. It will not be a chuck jaw, it will be a prismatic jaw. And the next step is to define necessary joint positions to assembly these components. So the first one is going to be over here. And as you can see, I still have in the background open project where I have these three coordinate systems. So SolidCAM can read these coordinate systems of the active project. So what I'm going to do, I'll click on this connection and I will create my linear position. And this is going to be my linear axis, where my axis is going to be called, I think L1, it's completely fine. It is linear, and axis vector. Axis vector is, let me see, if it's rotated like so, you can see it's not along y-axis, but it's minus y-axis. So I can set here -1, and over here, just put it on 0. My minimum limit will be 0. While the maximum limit, I will, for now, just put 100. I'll click OK. And I'm going to pattern it. So to pattern it, I just need to add one more around the Z-axis and just create it. As you can see, it will be visible and it will be there. I'll click OK. The next step is for my a linear, what we need to do is to use a linear and to find this position over here. And I can show you actually in two different ways how you can do it. The first way is by calculating the coordinate system. So I'll click on the main coordinate system, and my slave is going to be a linear coordinate system. I'm going to apply it. Pardon. My master will be linear, and slave will be Joe position 1. So if I apply it, it will be located exactly where I want it to be. But let me show you another way how you can do this. Let me just quickly just say this is position 1. And I'm going to copy or just add a static joint, which will be position 2. Position 2 is exactly the same position where is the first one. But this time I want to do it a little bit different. I want to show you a couple of ways how you can place this coordinate system at exactly the same spot as I did it without selecting on this, but instead selecting on the coordinate system on the 3D model of this component. So I'm just going to put this all to 0. And now what is necessary to do is to click on the z-axis as I did and just click on this surface. As you can see, it will automatically lower the position 2 joint there. The next thing that I can do is on my X, I can just click on the surface, and we are going to read the whole surface area and find the middle point. So you can just click on the X, click on the surface, and it will be there. Just perfect. Of course, because it was 0.3 up, so I'm going to move it for 0.3. There you go. 4.2, 4.2. That's perfect. So as you can see, the position 2, we define it even without the SolidWorks coordinate system. Okay, this is perfect. And inside the Joe, we have to do nothing. It's fine. The last step is just to save it. I'm going to save it as Gressel, TLV, and 7-exit. The next library, it's tool assemblies. It's easier to do. I will go into advanced view. I will load my components from the vault. Here it is, my predefined TLV file. And I'm going to assemble this fixture. I'm going to drag and drop my main. Then I'll place my linear. I think it's wrong. I made some position. Oh, the linear, it's okay. My main. Oh, I didn't shift my main. Okay. Nothing complicated. I'm going to edit my tool component. Let's do it quickly. There we go. So my main is going to have linear, and it didn't shift it. So let's do that quickly. So main, a linear, apply. Shifts are applied. There we go. But I think it's a good opportunity to show you something. Again, this didn't happen before, so I think it's good that I forgot to do this. This 50, if you can see, it's exactly at this surface that is just now selected. And let me show you what you can do here. So you can click on the Z and can shift it here. So that's great. But what if you want to rotate your X-axis to go into this direction, and you want to click on that on the model? So what is necessary to do is just click on this X vector and just click on this surface. It's going to make it normal to that. So as you can see, it's applied. But if you want to flip it, you click it again and just click on the same surface again. And there you go. I think it's a good example that I showed. So 7-exit, and let's create, again, tool assemblies. Load from wall. Take a main. I'll drop the linear. Let's see what we have now. Perfect. This is the results that we wanted. And the last step is the Joe. There you go. Everything is so nice. Everything is okay, but this assembly can't be used in SolidCAM yet. What we are still missing is to define where is my part mounting point, or where my part will be open, or located as default. This option is only available on main bodies. As you can see, it is located over here. It is not allowed to place it on the jaws, as the jaws are usually mobile components. It's not allowed to place it there. So therefore, the place where I want to be is I'm going to create it according to this coordinate system here. So just right-click, add part mounting. It is there, you can see it. And the same can be applied also here. So I just click on the Z-axis, and I want to place it here on this surface. There you go. Perfect. Let's see, I will go to the quick axis, and I see here the component axis, so I can now check if everything works fine. As you can see, it's perfect, but this 10 is not 10 millimeters between these. It's 10 millimeters from this linear to here. So the distance between there is a 20. I'm going to show you later how we can change it if you really want. Okay, so with this being said, let's repeat file save as, and your fixture is ready. So press LTLS, save, then exit, and this time I'm going to open a test part. It's nothing complicated one, just to test this fixture. So it is a simple prismatic part, 20, 75, and 50. And as you can see in this project, I have no fixtures defined at all. And the way how we are going to pull this from the toolkit is through the setup. Yes, you can go directly to a toolkit, but still you need to choose because what is the active one inside the setup. So I'm going to edit it here. There is, we call this a fixture page, and this is the part page. The fixture page is where you define your fixture relative to a table, while the part itself, you're defining the part position relative to fixture itself. So I'm going to open the toolkit from here, and I will pull it up from my assembly library, and you can find it here. And I'm going to do that in my machine preview. For my machine, I choose the Haas UMC 1000 SS, and this table over here now represents what I said at the beginning. This coordinate system of the table and the coordinate system that we defined in the picture is going to be matched now. So simple drag and drop towards my table station, and there you go. It is beautiful. Now here we have a component axis. It's set out to 30. You can set to any value, but please consider that this value over here, it is also considered as open position, while the value defined inside the setup, it's considered as a closed position. Right, perfect. So I'm going to accept this one. The picture is there. I will open my machine preview. I can also use this, I like this focus target option. And my part is exactly where my part mounting point was. So you can now click on the part. You will be able to see it also here. And I know that this part is 20 in height. So I can shift it here for 20. But in case you don't know, we can always use this new option, calculate the rotation and position. And you can just, it is a simple mate function with your user interface. So you can click on the face, and just click mate. If you like this position, you just can accept it. There you go. Now over here, because we have our jaws, we can also see a clamping axis. And the value here are taken actually from the toolkit itself, but you can change the close position. For those, you can use manual input by the scroll wheel. You can write some value, but also there are 3 new options: auto close on stock, also on the target, and set position. Auto close on stock and the target will work equally the same because this part and the stock are matching here. So I'm going to click on auto close on stock, and there you go. Now, please be aware that there can be these kind of situations, depending of also your 3D models. If you have a chamfer, it will stuck to this edge here. You can lift it for a couple of hundreds, and then it will work fine. But please, if you want to do it like so, And in most of the cases and Joes, it will work fine. But there will be still, as I said, some kind of strange Joes, especially with desired shape of the part, custom made for those. Auto close will not work. In that case, you have an option of set position, where similar interface for mating will appear, but with a difference that highlighted geometries that are located on this desired axis is going to be moved. So now you can click on this. Please be aware that my filter is a face and the vertex. I can click on the vertex, I can click on the face and just mate. There you go. Works perfect by far. Let's try to flip our Joes. How to do that? Here's my picture. So click on the Joe and just over here you have an icon to flip it. There we go. Let's see how that works. Now, because now I'm getting more stroke, I can rotate my part. So let me just rotate it for 90 degrees. I can now click on close on stock. I can go down a little bit, close on stock. I can also maybe clamp this on this edge and close on stock. I can close it, close on stock. Beautifully. Let me show you another thing. Let's test the position 1 and 2. So my Joe, by definition from our assembly, it is assembled in position 1 and we can't do anything about it. This component is simply linked. But if you want to unlink it and do it differently according to what is defined as my final assembly, you need to break this link. So I'm going to break the link. You need to do that twice because we are breaking the link first in assembly, then first in the vault, then in assembly, and now you can do it. So change it to the position 2. Let me show you. So position 2, it's changed the position of these. Now you can just restore the link and update the component. It will stay at the position 2. Zoom it here. Maybe I would like to flip it actually, but yeah, still, I think it will work fine. Perfectly. I hope you like this video. For any more, please stay tuned and stay with us. Thanks a lot. Bye.